systematic study of the elements. Mendeleev was the first scientist who arranged the then known 63 elements into groups and periods. This made the study of elements quite simpler because if the properties of one element in a particular group were known, those of the others could be easily predicted. While developing the periodic table, Mendeleev kept two things in mind. 1. Increasing atomic masses, and second, grouping of similar elements together. To be sure that elements with similar properties fall in the same vertical column or group, Mendeleev had to place an element with a slightly higher atomic mass before an element with slightly lower atomic mass. For example, cobalt having atomic mass 58.93 unified mass was placed before nickel having atomic mass equal to 58.71 unified mass. Because the properties of cobalt, that is Co, were similar to those of palladium, that is Pd, and platinum, that is Pt. Similarly, tellurium, that is Te, with higher atomic mass 127.6 unified mass, was placed before iodine, that is I, with lower atomic mass equal to 126.9 unified mass. Since the properties of tellurium were similar to those of oxygen, sulfur and selenium of group 6A. While the properties of iodine were similar to halogens, that is fluorine, chlorine and bromine of group 7A. Let us now learn about correction of doubtful atomic masses. Mendeleev's periodic table helped in correcting the doubtful atomic masses of some elements. For example, beryllium was assigned an atomic mass of 13.5 on the basis of its equivalent mass 4.5 and valency, which was wrongly calculated as 3. If beryllium has an atomic mass of 13.5, it should have been placed between carbon having atomic mass 12 and nitrogen having atomic mass 14. But no vacant place was available between carbon and nitrogen. Further, properties of beryllium were similar to those of magnesium and calcium of group 2A. Therefore, valency 2 was assigned to beryllium, which gave it an atomic mass of 4.5 multiplied by 2, that is 9. As a result, beryllium was placed at its proper position between lithium having atomic mass 7 and boron having atomic mass 11. At the time when Mendeleev gave his periodic table, gold and platinum were known to have atomic masses of 196.2 and 196.7 respectively. But Mendeleev placed gold after platinum in the periodic table and predicted that atomic masses of gold and platinum were incorrect. Later on, it was found that atomic mass of platinum was 195.09, which was lower than that of gold, 196.97. In a similar way, atomic masses of indium and uranium were also corrected. We will now learn about prediction of new elements and their properties. Mendeleev left some blank spaces or gaps in the periodic table for those elements which were not known at that time. He also made the bold prediction that these elements would be discovered in due course of time and would fill the blank spaces. He even predicted the properties of these elements in the light of the properties of the other elements present in the same group. For example, scandium, gallium and germanium were not known at the time Mendeleev proposed his periodic table. Mendeleev named these elements by prefixing a Sanskrit word eka, meaning first, to the name of the preceding element in the same group. That is, eka boron, that is, first elements after boron for scandium. Eka aluminium, meaning first elements after aluminium for gallium. And eka silicon, that is, first element after silicon for germanium. Later on, these elements were discovered and Mendeleev's predictions were found to be remarkably correct. For example, the properties of eka aluminium and eka silicon as predicted by Mendeleev and those found by Winkler for gallium and germanium respectively are very similar as shown on screen. Have a look at property of atomic mass, density, melting point, formula of oxide and formula of chloride of eka aluminium, gallium, eka silicon as predicted and germanium as shown on screen. Similarly, the properties of scandium were found to be similar to those of boron. Predictions provided convincing evidence for both the correctness and usefulness of the Mendeleev's periodic table. Further, due to the extraordinary success of the Mendeleev's predictions, chemists recognized him as the originator of the concept of classification of elements. We will now learn about position of noble gases. The noble gases like helium, symbolized as He, neon, symbolized as Ne, argon as Ar, krypton as Kr, xenon, and radon as Rn were not known when Mendeleev gave his periodic table. These gases were discovered much later because they are very inert and are present in extremely low concentrations in our atmosphere. Another strength of the periodic table was that when these gases were discovered much later, around the year 1900, they could be placed in a new group called zero group without disturbing the existing order. Some limitations of the Mendeleev's periodic table. Anomalous position of hydrogen. Hydrogen has one electron in its only shell, that is, K-shell. Alkali metals also have only one electron in their respective outermost shells. Therefore, many properties of hydrogen are similar to those of alkali metals. For example, like alkali metals, hydrogen combines with halogens oxygen and sulfur to form compounds having similar formulae as shown on screen. Thus, hydrogen can be placed along with alkali metals of group 1A of the Mendeleev's periodic table. Hydrogen has one electron in its only shell. In other words, it has one electron less than the nearest noble gas, helium, which has 2 electrons. Halogens, on the other hand, have 7 electrons less than their respective outermost shells. In other words, like hydrogen, halogens also have 1 electron less than their respective nearest noble gases, which have 8 electrons. Therefore, many properties of hydrogen are similar to those of halogens. For example, just like halogens, fluorine, chlorine, bromine and iodine, hydrogen also combines with alkali metals to form ionic compounds and with non-metals to form covalent compounds. Have a look at the element ionic compounds with metals and covalent compounds with non-metals as shown on screen. In other words, position of hydrogen in the periodic table is controversial. That is, no fixed position can be assigned to hydrogen in the periodic table. Even the placement of hydrogen along with alkali metals seems to be more appropriate because it is the first element in the periodic table and has the lowest atomic mass. Position of isotopes. Isotopes have same number of electrons and protons but different number of neutrons. Isotopes were discovered long after Mendeleev gave his periodic table. Isotopes are the atoms of the same element having similar chemical properties but different atomic masses. For example, hydrogen has 3 isotopes called protium, symbolized by H, deuterium, symbolized by D, and tritium, symbolized by T, having atomic masses 1, 2, and 3 respectively. Similarly, carbon has 3 isotopes, C12, C13, and C14, and chlorine has 2 isotopes, Cl35 and Cl37. Since in the Mendeleev's periodic table, elements are arranged in increasing order of their atomic masses, and the isotopes of an element have different atomic masses, therefore, they should be placed at different positions in the periodic table. Further, since the isotopes of an element have the same chemical properties, therefore they are placed in the same position in the periodic table. Thus, the position of isotopes in the Mendeleev's periodic table is anomalous. In other words, isotopes of all elements posed a challenge to the Mendeleev's periodic table. Anomalous position of some pairs of elements. Although the elements in the Mendeleev's periodic table have been arranged in order of increasing atomic masses, yet in some cases elements have been arranged on the basis of similarities in properties. As a result, an atom with higher atomic mass has been placed before an element with lower atomic mass. For example, cobalt, symbolized as Co with higher atomic mass, that is 58.93 U, has been placed before nickel, symbolized by Ni with lower atomic mass 58.71 U. Similarly, tellurium, symbolized by Te with higher atomic mass of 127.6 U, has been placed before iodine, symbolized by I with lower atomic mass of 126.9 U. This is contrary to the Mendeleev's periodic law. No resemblance with elements within subgroups. In the Mendeleev's periodic table, elements placed in a group have similar chemical properties. But there is no similarity in properties of elements in the two subgroups in a particular group. For example, lithium, sodium, potassium, rubidium and cesium present in group 1A are quite different from the coinage metals such as copper, silver and gold present in group. Different groups for similar elements. In some cases, elements with similar properties have been placed in different groups. For example, both copper and mercury have made similar properties, but copper has been placed in group 1B while mercury has been placed in group 2B. Uncertainty in the prediction of new elements. In Mendeleev's periodic table, the elements are arranged in increasing order of their atomic masses. But the atomic masses do not increase in regular manner in going from one element to the next. The difference in atomic masses between two successive elements is small among lighter elements. So, it is not possible to predict how many new elements are there, especially among heavier elements.